Hi everyone. In this video, I will explain to you the rational root theorem. Okay, let's begin with this important term in this rational root theorem, the word root. Okay, here. Okay, so when we say root or zero of a function, it is a number that when plugged in for the variable makes the function equal to zero. Thus, the roots of a polynomial p of x are values of x such that p of x is equal to zero. Now, in a rational root theorem, it states that if the polynomial p of x equals a sub n, x raised to n, until plus a sub 0 has any rational roots, then they must be in the form of factors of a sub 0, which is our constant, over factors of a sub n, which is the numerical coefficient of the leading term. Now we will take in consideration the sign, so that's going to be positive, negative, those factors of constant all over the factors of our the numerical coefficient of the leading term. Now you might be thinking, what is the importance of rational root theorem in, let's say, solve mathematical problems? So let's say the teacher asks you to find the roots of a cubic function. So let's say this function, okay, this cubic function, 2x cubed minus 3x squared minus 11x plus 6. The first thing you're going to do is to narrow down the number of possible roots. So to check whether that particular number is a zero or a root. Why is that? Can we use a specific formula? I think there is a formula for this, but it's a complicated formula. The best thing to do for me is to use the rational root theorem first, and then use the factor theorem. I also have a video of that. Use the factor theorem and some lessons in polynomial to figure out or to find out the zeros of this cubic function. So you are going to start with the rational root theorem. Okay, so let's try to apply that rational root theorem here. We will not solve this function. Okay, we will not find the zeros, but we will try to find out all the possible rational roots or zeros of this polynomial. Let's begin with this factors of 6 and then factors of 2. So factors of 6, that's the constant. Factors of 2, why 2? Because that's the numerical coefficient of the leading term. Our leading term is here. Okay, this is the constant number. So which means that will be positive negative factors of 6 over factors of 2. We all know that the factors of 6 are 1, 2, 3, 6. Factors of 2 are 1 and 2. And then we will separate that 1, 2, 3, 6 over 1, and then 1, 2, 3, 6 over 2. So we will have this, and we also have that. And then let's try to, simplify each number here. So 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and 6 over 1 is positive 6 or positive negative 6. So we have positive negative 1, positive negative 2, positive negative 3, and positive negative 6. Also here we have positive negative 1/2 because of this. This one is because 2 over 2 is 1. That 3 over 2 is because of that. That positive 3 is because of 6 over 2. Now, as you can see, we have two 1s here, so we can just get rid of that. And also the 3 here, which means that these are the possible rational roots of this cubic function. Okay, so we have 2, 4, 6, 8, 10, 12 possible roots. Okay, so these are the possible roots or zeros of the given polynomial. These are the three things. These are the things you need to remember also. But only 3 of them are the rational roots or possible rational roots or zero. Why is that? Because we are dealing with a cubic function. So this gives us an idea, okay, the number of roots that that a function has. So if it's x, that means there's only one value of x. If you see that it's a cubic function, that means there are 3 possible zeros. Maybe 3 of them are rational functions, rational numbers rather. And yeah, here we go. So that's it. So since we have this quadratic or cubic function and it's a third degree polynomial, it means that it has 3 roots or zeros. maybe those three roots are imaginary, maybe they are rational, right? But what we know is that there are three roots. Okay, so that's it for the rational root theorem. I hope you understand that. Again, the rational root theorem is actually used, one of the methods, the first method that we will use to find the zeros of any given polynomial, especially if it's a third degree polynomial going up. Because if it's quadratic equation, we don't need rational root theorem. We can use quadratic formula. If it's linear, we can solve it. We can solve it easily. Okay, so that's it. Thank you for watching. I hope you learned something.